welcome to this material science class. So in this class we are going to learn about the fracture. Whenever the force is applied on the body, stress is induced in the body. When tensile force is applied, the force which tends to elongate the body, the force which tends to increase the length of the body, that's called as tensile force. The tensile force is applied, strain is produced in the body, and when stress is increased, strain also increased. When stress exceeds a particular limit, the atoms are displaced permanently, and when further force is applied, then the atoms move from its original position, and when the number of atoms are moved from their position, crack is developed. So this crack reaches the outer surface, then the material gets fractured. So whenever the force is applied on the body, when it goes beyond the elastic limit, then so many voids are produced due to the displacement of atoms inside the body. So one particular void increases in its size whenever the force is increased further. When the external force applied on the body is increased further, the void increases in its size and it reaches the outer surface. This is called as crack propagation. Crack, when the voids are formed due to external forces applied, it is called crack initiation. When the void increases in its size and it reaches the outer surface, means it is crack propagation. So when the void reaches outer surface, the body gets fractured. There are two main types of fracture. One is ductile fracture and is brittle fracture. Whenever the fracture occurs in ductile material, it's a ductile fracture. The material which can be elongated in the form of wire, thin wire or frame, it's called as ductile material, aluminium, for example. It can be drawn as a thin wire, MS wire, thin wire, thin rod. The property has more ductility. Whenever fracture occurs in such materials, it's called ductile fracture. Ductile fracture, when the force is applied, the void in a particular place inside the body, it increases in its size. At the same time, external diameter or external size is reduced, a neck formation takes place. On further increase of the external force applied on the body, the void further increases in its size and reaches the outer surface. Therefore, the body is fractured in cup and cone form. It can be arranged again, but in the fractured portion, we may be having small projections. It's called cup and cone form. But in the case of brittle materials, the materials which can be broken easily, when it's dropped on the floor, it's broken into pieces. Such materials are called as brittle materials. When the force is applied on the body in brittle materials, when the force exceeds its elastic limit, then the voids are formed, and the void may be increased in a particular void and reaches the outer surface. Here there is no neck formation. There is no plastic deformation. Immediately it breaks after a particular time. There is extensive deformation in the case of ductile fracture. Before the body gets fractured, it elongates more, a neck formation occurs, and slowly it breaks, and more force is required for occurrence of this fracture. But in the case of brittle fracture, it occurs suddenly. Whenever limit is reached, elastic limit is reached, then after that, when the external force is applied, when the external force applied on the body is increased, then it gets fractured immediately. Suddenly it occurs. It doesn't take much energy as that of the ductile material. It occurs in the brittle material generally. Other fractures or transgranular fracture. So every metal, every body contains grains, and there's a small gap around the grain. This is called grain boundary. So whenever external force is applied on the body, the atoms in the grain boundary has less resistance to external force, so they are displaced easily along the grain boundary. So fracture occurs along the grain boundary in such materials. This is called transgranular fracture. Another is fatigue fracture, when the force is applied repeatedly, again and again, several times over a particular material surface, then it gets fractured because the force is applied again and again. When it exceeds the last endurance limit, then crack may be developed. Therefore, in engineering field, in order to avoid such failure, the material should be treated properly, and suitable material should be used for a particular purpose. So this fracture occurs whenever there is stress involved in the body exceeds a particular limit. So whenever the force is applied on the body, the void increases, the size of void increases. At the same time, the void is inversely proportional to the stress. And when it reaches the outer surface, it gets fractured, we've seen. Therefore, the radius of the void, when it increases, the stress is inversely proportional to the radius. It's called Griffith's theory. So the fracture, it's an important subject. You may expect one question from fracture. What is fracture? What is the types of, what is the mechanism involved in fracture? Mechanism involved in fracture is nothing but fast growing fracture in the case of brittle materials. And in engineering field, when a material is used for a particular purpose, it should not get fractured whenever the external force is applied on the body. Therefore, engineers should be able to understand the types of fracture and way to avoid such a fracture in its design. So study all the types of fracture and also study about the Griffith theory. And we shall continue the class the next day. Thank you.